Welcome to video 2, where we will look at the anatomy of an experiment. So what are the different things that make up an experiment? So what I'm looking at here in this is the dependent and independent variables. I also want to look at the point of controls and experimental variables, or control and test experiments. So let's consider an experiment where you have two sports drink. One is your regular sports drink A, the other is identical to sports drink A, but has caffeine in it. So we'll call this sports drink 2. And we want to measure the effect that this sports drink has on running performance. So let's look at the different variables. So the independent variable in this scenario is going to be the thing that you vary. So how you can remember this is the independent variable I will vary, and it will vary independent of anything else in this experiment. You know it's going to change because you are physically changing it. So it's the independent variable. So in this experiment, the independent variable would be the drink that they get. They would either get sports drink A or they'd get sports drink B, which has caffeine in it. So the only difference here is that they have caffeine. The dependent variable then is the outcome that you measure. So the dependent variable depends on whether the independent variable will have an effect. So in this experiment, you might get two groups of people. One group you measure their running performance, and you do that for both groups, and then you give them sports drink A, and you see if their running performance increases. So what your dependent variable would be in this scenario would be the amount of time, or the amount of time that the athletic performance changed by. So it might be a negative time if it increased. Control variables then will be everything else in the experiment that could possibly change, but that you don't want to change. So these are going to be things that you keep the same. So everything else in the drink A is going to be the same as in drink B, except B has caffeine. The group, ideally, you would choose individuals and put them in each groups that are very similar to each other. So same general history of athletic performance, same training background, etc. You'd use the same type of stopwatch, or same time of timing, or same sort of variable. You'd be measuring them on the same track, etc. If you would want to keep everything controlled then. The experimental variable is the same thing as the independent variable. It is the one thing that you've changed. So your experimental value is whether or not you're giving these individuals caffeine. Sometimes you might hear, instead of variables, control experiment and test experiment instead of experimental variable. So your control experiment would be your experiment where you don't alter the independent variable from what it normally would be. So it would be this group A that gets the regular sports drink would be your control experiment. Your test experiment then would be this second group where they're getting the caffeine in it. So you might also call this the control group and this the experimental group, because they're getting the experimental caffeine in this drink. Now, oftentimes when you report the data, you're going to report it in graph form. So let's say that you're looking at the seconds that they improved, and you're measuring the effect caffeine had, so the type of drink. So B had caffeine, A did not. So A, these individuals would have improved by 0.1 seconds on average, and B would have improved by 0.5 seconds on average. Now, likely this isn't going to be a constant value. It's going to be some sort of mean with some deviation with the actual performance increase. And you'd perform statistics to see whether that's statistically significant You might also want to know if it is really significant in the matter of the amount of time. So if it's, you can have something that's statistically significant, but the difference is 0.001 seconds, in which case you wouldn't say that it is really significant in the amount of time they improved, because there's, even though it's statistically significant, it's not a large marginal change between the two groups. So you want to factor both of those things in. Looking at graphs, typically you're going to have the dependent variable going on the y-axis and the independent variable going on the x-axis. So you're usually doing the things that you change down here on the x-axis, and then your measurements go on the y-axis. All right.